On page 57, I want to review with you how to solve algebra equations. Or maybe no one has ever explained how these work. So, whichever it is, let's take a look at the golden rules for equations. If you can remember these three rules, you can solve just about any equation. Number one, if you do it to one side, you must do exactly the same thing to the other side. And we're talking about the two sides of equals. And you'll see that in just a second. Number two, you move terms using inverses or opposites. The inverse of add is subtract. The inverse of multiply is divide. And number three, you keep working until you have one variable equaling one constant. And that is called a solution. So I've given you some examples of different types of equations, and I'm going to walk you through how to solve these using the golden rules. So the first one is an addition equation, and I know that because of the addition sign right there. So I'm writing it down. I'll have to squeeze these in. X plus 5 is 10. Now you can probably look at this one and tell me what the answer is going to be. But if you couldn't, here's what you would need to do. Separate this equation out like so. And ask yourself which side has the variable. And clearly it's this side. It's the x. So I'm going to let this be the variable side and this be the constant side. It doesn't matter. It works the same way if constant comes first. So look at the variable side, which is right here, and tell me which of those terms is on the wrong team. Is it the x or the positive 5? It's the positive 5. Because positive 5 is a constant, and therefore it needs to be on the constant team. So how do the golden rules tell us to move terms? It says that you move using inverse. So the inverse of plus 5 is minus 5. And it says if you do it to one side, you have to do it to the other side. And here's what makes this work. These two terms cancel. If I have 5 pieces of candy and I eat 5 pieces of candy, the candy's gone. It's canceled out. So I'm left with a variable. And on this side, I have 10 take away 5. So the solution to that equation is x equals 5. And I always like to put my solution in a box just so I can tell that's the answer. One variable and one constant. If you understand that, you can do any algebra that comes your way. This is what algebra is. You want it to make this shape. The problem should get smaller as it goes down the page. If it doesn't, something is wrong, and you have to cancel on every step. If you need to, stop this video and watch that again. Okay, this one. I have an x minus a 12.6 equals a 32.08. Draw the scaffolds. It will help you if you need it. And ask yourself, where is my variable? We need to isolate that variable. And so this is the constant side. This is the number side of the problem. Ask yourself, who's on the wrong team? And it's the number. So we're going to move it with its inverse, which is the opposite. And if I do it to one side, I have to do exactly the same thing to the other side. And just like that candy I was eating, that set of terms is gone, leaving me with my x by itself. That's what I want. I need x to be all alone. And on the constant side, I have 3208 plus 1206. That is going to be 4466. So the solution to this problem, x is 44.68. I think I said 66. I'm sorry. And that is your solution for number 2 there, the subtraction equation. All right, a multiplication equation. We have 0.26 times a equals 1.56. So determine your variable side. And your constant side. And ask yourself, who's on the wrong team? A is a variable. It can stay on this team, but the 0.26 has to go to the other team. And it's going to go by the inverse. That's the only way you can do this. So we're going to divide this side by the 0.26, and we're going to divide this side by the 0.26. And every step of the way, I have to cancel or something's wrong. So use your calculator to do 1.56 divided by 0.26. The solution will be A equals 6. That is the one number in the world that will balance this equation. Or I should say the one value in the world that will balance the equation. Okay, this one's a little more of a challenge. It's a division equation, but the variable is on the bottom. And I gave you this one so that you will be able to do the trigonometry that's coming down the line. So let's think about this one. The same process works. The golden rules never change. They never vary, and you can never break them. So we have a variable on this side. I am going to move it to the other side because it's on the bottom of a fraction. And I'll show you what I mean. I want to get rid of that m on the bottom of this fraction. So I'm going to say that this is the constant side. So I'm going to take multiplying is the opposite of division. So let's put the m right there. And if I do it to one side, I have to do it to the other side. These m's will cancel. So I'm left with 52 equals 13m. And we still have a term on the wrong team. Who's on the wrong team here? Is it the m or the 13? It's the 13. So I'm going to divide it out. Here is the canceling that I have to have every step of the way. 52 divided by 13 is 4. So this solution, m equals 4. These get gradually more difficult, but the golden rules never change. You can never break them, and they work every time. Then we have 25g minus 5 is 220. So I don't have any wonky fractions here. I'm just going to go ahead and set up my scaffold. And I can tell you where the variable is. It's the g. So we got a lot of players on the wrong team. And we just gradually have to move them to the right team until there's nothing left to move. So which terms are on the wrong team? The only thing that can be on this side is that g. It's a variable. So the easiest one to move, at least initially, is this one. I'm going to do plus 5. And if I do it to one side, I have to do it to the other. So this will cancel. And I'm left with 225 on this side and 25g on this side. Now, which term is on the wrong team? There's one of them. It's the 25. So let's divide it away. And if I do it on that side, I have to do it on this side. Cancel. And so I'm left with g equals 225 divided by 25. And that is 9. So the solution to this one, g, the variable, equals 9, the constant. And when you get them down to one variable and one constant, you have yourself a solution. All right, then we have a squared equals 7225. So we have a to the second power equals 7225. Let's draw the frame. At least in your mind, draw the frame. It's very clear where the variable is. And I don't have any of those funky fractions. So we'll go ahead and solve this one. Who's on the wrong team? That too. So how do I get rid of a square? There's only one way. I have to take the square root. And if I do it to one side, I have to do it to the other. So when I take the square root over here, you don't see it, but there's a 2 there. Square root. So those 2's are canceling each other. There's a 2 there as well. So that leaves me with a. And on this side, I need to know the square root of 7225. And go ahead and use your calculator. I did. And I got 85. So the answer to this one, A is positive or negative 85. Because, let me show you a little thing you need to know about algebra. Let me color the solution first. And then I'm going to go over here. I think I'm going to go up to the top of the page to show you this, because I need my space. If you take your calculator and say 85 times 85, actually, let me just bring this down here, because let's just put it right here beside the equation itself. We have room. 85 times 85 is, you can do it on the calculator, but you're going to get the power, 7225. If you do negative 85 times negative 85, you will also get positive 7225. Because when you multiply two negatives, the answer is always positive. So technically, there are two solutions to that equation. It's plus 85 or minus 85. And that will happen anytime you have an even numbered exponent. So I would be not doing a very good job if I didn't remind you of that. It's not going to be that important with what we're doing. We'll always take the positive solution, but just be aware that it can happen to be negative. All right, on this one, we have the cube root of y is 8. So the equation is the cube root of y equals 8. Your rules never change, and you can never break them. The variable is sitting here. It's the y. And the constant is sitting here, the 8. So who's playing on the wrong team? It is this 3. So the way to get rid of that 3 is to multiply, because this is division, so it is to multiply the whole term by 3. And if you do it to one side, you have to do it to the other. So this 3 and this 3 will cancel with the root sign, so you're left with y. And over here you have 8 to the third power, which is 8 times 8 times 8. That's 64 times 8. And I used my calculator. That is 512. That's your final constant. So for that one, and this is not an even exponent, so it is 512. Okay, a couple more, and we'll be done. These are just review problems. If you need more examples, ask your instructor. They can help you with more of any of these that you want to see. All right, the next one is called a separated variables problem. And we have 2b plus 5b equals 3b plus 16. So when I go to draw my scaffold, I've got b's all over the place. I've got variable and variable on both sides. So before you decide where you want to put variable, let's do some simplifying. The first thing I want to do is combine these b's into one term. So think of it as 2 bananas, or 2 boats, or 2 books, or 2 babies, whatever you want b to represent, plus 5 of the same thing. So 2 plus 5, that gives me 7 of those b's. And then on this side, I still have 3 b's, and I have a 16. So I have 2 b terms. I have this one and this one. The 7 is bigger than the 3, so I'm going to let my variables be on this side. And sometimes that will let you avoid negative numbers. I also like the constant that's sitting over here. That 16 is a constant, so let's leave the constant alone. Who's playing for the wrong team in this picture? In other words, which term needs to move? This one needs to cross over to the variable side of the problem. So to do that, I'm going to subtract it from this side. If I don't see a sign, it's positive automatically. So I minus it there. I do exactly the same thing over here, and I cancel right here. So we've got everybody on the right team. We just need to finish this problem. 7 minus 3 is 4 B's. And over here, I have a positive 16. So this is actually a 3-step problem. I'm going to have to divide both sides by 4. And I'm left with a variable and a constant. And when I have that, I'm done. So the solution to this problem is B equals 4. And then we have one left, and it will involve distribution. So I'm going to move this one over and do distribution right here. So we have 15 times 2x plus 3 in parentheses, and that is 60. So I can tell you where constant is. And we're going to have to use some distribution to simplify this. We have to get rid of those parentheses. So to do that, I'm going to take that 15 times that 2 to get 30. And we're carrying an x on that one. And then 15 times positive 3 or plus 3 is positive 45. And then over here, that 60 just keeps falling down the line. So my variable is here. I like to wait until my parentheses are gone to decide that, but in this case, it's clearly there. And then I need to ask myself, if this is the variable side, who's playing on the wrong team? You have this term and that term. Both of those are going to need to go over here because they're constants. But we can only move one at a time, and I like to start with this one because I can subtract it off both sides, cancel this mess, and I'm left with 30x equals 15. And then we still have a player on the wrong team. We have that 30. That needs to be divided away. Be careful. The answer is not 2. X is 15 divided by 30. You can do it on the calculator, or you can do it that way. Just simplify it. So in this case, the solution is x equals 1/2. It would be appropriate to say x equals 0.5 as well. So you have seen an example of every kind of problem that I could think of, every basic kind of problem. You're going to need these skills to work with the electricity problems that are coming. So if you don't understand these, I would encourage you strongly to talk to your instructor, get some extra tutoring on this so that you are comfortable with solving equations before we get to the really difficult ones. The next ones you will see will be the Ohm's wheel, and the wheel will tell you the equation to solve, but we have to use the algebra to do that. So it's important that you're pretty comfortable with these. And if you bring this book and show your teacher, this is the problem I'm having trouble with, or the problems, he or she can help you get those worked out.